Okay, so this is going to help you, this little video, to finish your calculations for the specific heat of a metal lab. So you need to run the simulation with the unknown metal 1 or 2. I did my data with silver, so you cannot use my data because it's not unknown 1 or number 2, okay? So I just chose some different metal, and I recorded the initial temperature. You want it to be hot, and water and its initial temperature, and then at the simulation these two are going to be the same final temperature because they're in the calorimeter together. Okay, so I labeled these as final temperature. This is my initial, this is my initial. Okay, so when we start doing these calculations, number 7 says temperature change of the water in the calorimeter. So I'm going final minus initial. My final is number 5 and my initial is number 2. So what you're going to find out is I actually have the wrong one. My initial water is number 4. I did that wrong. Good thing we caught that. Okay, so number 5 is the final temperature of the water and the initial temperature of the water. So 21.52 minus 20. And I'm going to get 1.5 degrees Celsius. Using my sig figs, because 2 decimal places, 1 decimal place, I'm going to get 1 decimal place in my answer. And then for the metal, same final temperature, 21.52, but my initial temperature, this is number 2, is 130 degrees. I'm supposed to make that a sig fig. Okay, now when I subtract these, this is going to come out negative. And what that tells us is the metal was losing energy, and that's what was happening because the metal was cooling down and releasing its energy to the water. So I get negative 108.48. And if I round this with my sig figs, this one has no decimal places, it would be negative 108 degrees Celsius. Okay, so now I'm moving along to calculate the energy. So we know that heat lost equals heat gain. That's the first law of thermodynamics. That's what you were supposed to be proving, supporting in your very first lab with the hot water and the cold water. So on this one, we're looking at this energy calculation. We know the water. So the water's mass is 200 grams in my trial. And my change in temperature is 1.5. I just did that. And I know the specific heat of water because it's in my notes and I've used it a bunch of times on homework and the first lab. So the 4.18 is a standard only used for water. Okay, so when I multiply all of these together, I get 1254. So 2 sig figs is here. So this is what my calculator says. So I'm going to round this to 1300 joules of energy. So that's how much energy the water is absorbing. So if heat lost equals heat gained, the amount of energy of the metal sample is going to be the same number. It's just going to be negative. So 9 and 10 should be quantity same, but the sign should be different because the metal's losing heat and the water is absorbing heat. Okay, so then we're going to do the same thing for the metal. We're gonna do this because we don't know the specific heat of the metal. That's how we're going to identify it. So we're going to go back to this equation. So I just rearranged this equation so it would be solving for specific heat, which is what we would be doing. I did it in the other video. I usually just plug them in and divide, but some people like it like this, where you set up the equation first, so I thought I'd do it a different way. So this Q is going to be number 10 divided by the mass is number 1, and the change in temperature of the metal is going to be number 8. Now those are data numbers, so you're going to have to plug your numbers into it, and I want to see them on your paper like I'm doing here. This is showing your work by plugging your numbers into what I'm doing. Not my numbers, your numbers. And then number 8, negative 108 degrees Celsius. Okay, so when I do this, it is going to come out positive because these two negative signs are going to cancel each other out. And if you were by chance going to forget that, you know, like accidentally dropped one of your negative signs and this came out negative on your calculator, you should go, oh yeah, that's right. Specific heats are never negative. Masses are never negative, okay? Energies are negative because that tells us that they're being released. This energy is being released because the temperature is going down. Okay, so specific heat and mass, never negative. All right, so it looks like I'm going to do 2 sig figs, so 0.24 is what I'm getting. Okay, so then what you're going to do is take this value, and there is a chart on the lab that has you look up the values for the specific heat. Okay, so you're going to look up the specific heat. What I would do is look this up, and then you're going to see what metal you have. Okay, so if I was doing that on this, compare it to a chart of specific heats, and you'll notice that I got 0.24, which is exactly silver, so that's what I would choose if I was doing it. I know it's silver because that's what I'm doing, but if I didn't, that's the way you would do it. You would take this value and look up the values on the chart and match it with whatever it matches with. And then, even in the lab, this one actually comes out pretty accurate. But being a virtual, it looks like they're even more accurate. Okay, so the theoretical value that I'm seeing here on this is 0.240 joules per gram degrees Celsius. So this is what we call our theoretical value. Number 11 is called our actual value. It's like what we really got in the lab. Okay, so this one's theoretical, and then number 11 is actual. So when we plug it into this formula, theoretical minus actual, these are absolute value signs. I really don't care if it's negative or positive. That doesn't help me out over the theoretical. So what we're going to do is we're going to take number 13 minus number 11 and make it positive, whatever you do, big minus small, and then divide it by number 13 times 100. That's going to give you your percent error. So on this one, I have it's going to be minus 0.24 because my data is so good, because I got it off the computer, times 100. This is going to be 0, so everything here is going to be 0%. Maybe yours doesn't come out to be 0. I don't know how the runs are going to go, but this should really help you find the numbers that you need to do for which of the calculations. So these boxes right here are just to show your work and make sure you're plugging in your numbers. These are shaded out because there's no work to show. All right, hope that helps you guys out.